to pick the healthcare plan that we picked, because we can look at, on average over time, what has happened in our healthcare plans. Which plan makes the most sense based on our average, or weighted average. Should we put PV cells on our house? Let's calculate average energy costs. Let's see how that extrapolates out over time. I mean, it's amazing how you can use this. So the idea of a weighted average is exactly the same as what Taryn said for an average. But the weights are going to be those frequencies. It's when the data doesn't just come at you in raw form. The raw form of this data would be very, very hard to look at. It'd be a bunch of 2s and 3s, like 2, 2, 2, 3, 3, 2, 3, 3, 2, 2, 2, 3, 3. And if you had it like that, you kind of have to add them all up and divide by 290. But my God, that'd be a total pain. So what we're going to do is we're going to do a weighted average. Now, the way you do a weighted average, let's get this out of here, although I love Faith's definition of probability. It's actually tied to this, believe it or not. A weighted average is still, you still divide by the number of data points. Still. But what you do is, you take each data point number 1, and multiply it by its frequency. So you take data point number 1 and multiply it by its frequency. And then take data point number 2 and multiply it by its frequency. I'm using this word frequency. Is that okay to use the word frequency? Let's make sure. Exactly. Thank you. What does it mean? What does it mean when I use this word frequency? How many times it occurs? With what frequency did it occur? Thank you. I realize that I'm using this word frequency, but we better define what it means. So in other words, it's how frequently each of the individual data points occurred. That's all. That's all. Just using a new word. Sorry. I'm sorry. I'll lapse into 243 mode there for a minute. Please.
So just so I have it.
Go ahead. Go. Yes.
Frequency, is that the 160?
Yes, ma'am. It's the 160 and the 130. So in other words, this would be data point 1, frequency 1, data point 2, frequency 2. Can this be expanded out to more than just 2 things? Of course it can. I might send you guys home with an experiment to do before class on Wednesday, which is the same, using the same kind of coin idea, but measuring something different. We'll see how this goes. Fair enough? Okay, good. Let's figure it out. Let's figure it out for our results. So our first data point was 2 flips. 2 flips? How many times did that occur? 160 times. Plus, here's your sum. Terry, your adding is right here, adding up all the data points. It's happening right here and right here through multiplication, because as Carrie said, stop adding. Sean's is like, got invented multiplication. Thank you. Plus 3 flips times, how many times? 130 times. Now, you might have noticed something. The number of data points is also equal to the sum of all the frequencies. 160 here, 130 here is 290 altogether. Yes, all you got to do now is figure out what this is. So we've got 2 times 160, that's 320 flips, plus 390 flips, yes? Divided by 290 altogether, that's 710 flips over 290 trials. How many flips is that to the nearest tenth? Looks like 2, not 0.3, 2 point something?
2.45.
2.45?
Yes.
Thank you. Thank you, friends. It takes about 2.45 flips on average. Does that make sense?
Yes.
On average, yes.
Oh! I love the process of answering that question I just heard. I said, does it make sense? 2 folks said yes, yes. And then Blake followed it with on average. And I got very excited about that. Because it doesn't make any sense realistically. You cannot flip a coin 2.45 times, can you? But can't you average 2.45 times? You can average a number that, 1990, 2.5 children per family. That was in the census. 2.5 children per family in 1990. What does that mean? It means that out of every 10 families, there were 25 kids spread around in some way. Some had 3, some had 2, some had 4, some had 1, but over 10 families, 25 kids. Now,
That it's never going to touch 0, right? So it's
good. Yes. This one actually, thank you, Carrie. I wasn't going to go in here with this, but let's go there. Carrie just asked for a graph. Thank you, sister. Let's graph.